Good afternoon. My name is Bruna. I'm a civil engineering student at the Adventista University of São Paulo, and the title of the work that I will be presenting is Feasibility of Thermal Analysis of Constructive Systems using the Ahp Gaussian method. And the authors are me, Fernando, and Marcos dos Santos. So, the building envelope has a dominant role in regulating the thermal energy of the environment, with about 61% of the electrical consumption of residences going to heating and cooling systems. Because of this, studies are conducted to increase buildings' thermal performance and energy efficiency. For this study, the materials properties and construction techniques are analyzed and chosen according to the local climate. Several variables and parameters influence the results of these studies. For this reason, the decision-making about the best combinations of construction techniques, materials, and thermal properties may become complex, making adopting multi-criteria decision-making methods interesting. Among these methods, there is the Ahp Gaussian, developed by Santos, Costa, and Gomes for selecting the best options of warships for the Brazilian Navy, and that has been utilized in other works, such as hospital acquisitions and the selection of a large cargo aircraft model for the Brazilian Air Force. So this work aims to analyze the applicability of the Ahp Gaussian method for assisting decision-making in thermoenergetic simulations, studying the viability of the application of EPS core panels in the different Brazilian bioclimatic zones that are cities with different climates. The methodology is formed by 7 steps, beginning with the definition of the building systems to be analyzed until the execution of the computation simulation, and followed by the determination of thermal performance, indication of thermal comfort hours, and the analysis of the building systems with the Ahp Gaussian method. For the simulations, the building systems analyzed were the masonry with ceramic blocks and the EPS core panels, both with dark and light colors. The study was done considering the social housing unit built in the city of Curitiba, and several scenarios were simulated, varying the cities, the building systems, and the ventilation and shading conditions. For thermal performance, the maximum and minimum operative temperatures were considered, the percentage of hours within the acceptable operative temperature range, and the total thermal load. In thermal comfort were defined the upper and lower limit for operative temperature, and then calculated the percentage of discomfort hours. In the Ahp Gaussian, 7 steps were followed, defining the decision matrix, normalizing the values, calculating the mean, standard deviation, and the Gaussian factor, and finally obtaining the ranking. Because the analysis was performed for cities with different climates, some criteria had different definitions. For the minimum operative temperatures for cities in zone 1 to 3, the values were Prof monotonic, while for cities in zone 4 to 8, they were cost monotonic. And the default decision matrix for all locations had as criteria the maximum and minimum operative temperatures, the percentage of hours within the acceptable operative temperature range, the total thermal load, and the percentage of discomfort hours. And the alternatives were the building systems. So the analysis of the results began with the thermal performance, with the first parameter being the maximum operative temperature. And it was observed that systems with dark colors presented the highest values, and that in zone 4, 5, 6, 8, and 1, the EPS always presented the highest values, while in zone 2, 3, and 7, the Mensury presented the highest values. For minimum operative temperatures, the EPS in all locations presented the highest values. And in the variation of this parameter, it can be seen the decreases that occurs with the shading of the windows and the use of light colors. To the percentage of hours within the acceptable operative temperature range, in zone 4 to 8, the Mensury represented the highest percentage, and the EPS dark and EPS dark with shading the lowest. For zone 1 to 3, in general, the highest percentage was obtained with the EPS, and the variation of the building systems was more significant in zone 3 to 6. In total thermal load, in zone 4, 5, 6, and 8, the building systems with dark colors resulted in the highest consumptions, while in zone 1, the EPS dark with shading decreased by 50.39% the thermal load in relation to the Mensury with light color. In the percentage of discomfort hours, in the color cities, the building systems with EPS presented the lowest percentage, while in the hot zones, the situation was reversed. And when performing the HEP analysis with the previous parameters, it was seen that in zone 5, the EPS with light color had presented a much better performance than the other systems, while in zone 2, there was no significant difference between these systems. And in the ranking obtained, the zone 4, 6, 7, and 8 showed a pattern with the Mensury with light color being the best solution and the EPS with dark color being the worst. In zone 1, 2, and 3, there was no pattern, but the EPS was among the best solutions. And in the conclusions, it was seen that the Mensury and the EPS core panels with dark color should be avoided in hot zones. And even using light colors, the EPS was inferior to the Mensury due to an increase of 39.95% in thermal load. On the other hand, in cold zones, better performances were obtained with the EPS due to a 34.82% decrease in cold discomfort. And these results made clear that the Ahp Gaussian method brings benefits to analysis of thermoenergetic simulations, reducing time and effort, allowing informed decisions, and the development of studies considering more parameters. And the limitation of the use of the Ahp Gaussian for analysis of thermoenergetic simulations is the impossibility of using parameters that present negative values. So, and finally, I would like to thank you all for your attention, and also the Adventista University of São Paulo, the Federal University of São Carlos, and the Militar Institute for supporting this research. Thank you so much.